This is Leetcode 198, and the question is, you are a professional robber planning to rob houses along the street. Each house has a certain amount of money stashed, and the only constraint stopping you from robbing each of them is that adjacent houses have security systems connected and would automatically contact the police if adjacent houses were broken into on the same night. So we have a list of non-negative integers representing the amount of money in each house, and we determine the maximum amount of money that you could rob in a night without alerting the police. So if we have like 1, 5, 2, 6, 3, the maximum amount of money we could rob in this case would be 11, because we could rob this house, and that would give us 11, and no other sum of houses that don't break our constraints would lead us to a number higher than 11. So that's kind of the main idea. And to approach this, we could use dynamic programming, where we get our answer at a given index from the answer at the index before, or indices before. So assuming this final house did not exist and we got our given answer here, and we just added that house, and we just added the house here, we could use our answer from this list, from this subset of the full list. So the value here, or the value of this subset, or the maximum amount at this for this subset, plus the value of like 3, or the maximum amount for this subset. And that's kind of the main idea with the code, and you would understand better if I write it in actual code. So interrupt vector int and nums. So the vector's name is nums, and we could do a quick check if nums are empty. So if our list is empty, we would want to quickly return 0. If nums the size is equal to 1. So if we have just one element in our list, we could just return that element. And if we have a list greater than 1, we would reach here, and we could create our answer vector from which we would do our bottom-up approach of dynamic programming in. So nums the size, and all initialized to 0. So we could go and 0 is equal to nums 0, and 1 is equal to the max of, so the greater value between nums 0 and nums 1. And so these are our base cases in our dynamic programming approach. And we could initialize our for loop to be 2, I equal to 2, and I is less than ans.size I plus plus. So we could go ans I. So at our current index, we would want to get the max of and I minus 1 or and I minus 2. So the maximum if our current house did not exist, or the maximum if our current two houses, if our most recent two houses did not exist, plus the value of our current house, because with this we would not be breaking the rule of not robbing adjacent houses. And we could return and nums the size minus 1. So the last index, which is the answer we want, that contains every house. Yes, so this is Leetcode number 198, house robber. Please like and subscribe. Thank you.